So we're going to insert a spreadsheet, and you need to type in the headers here, n for this one, and this is cubes. So you've already filled in the table a little bit, 1, 2, 3, 4, 5, 6, and you've already filled in the number of cubes used, 1, 3, 6, 10, 15, 21. Okay, this is when you've got to decide what kind of model would fit that data, and one of the best ways is looking at the method of differences. So from 1 to 3 it goes up by 2, then it goes up by 3, then it goes up by 4, by 5, by 6. So the first set of differences isn't a constant, but then when you check again you find the second set of differences is constant. You could even write it in here just to check, look, this is first diff. Oh, we won't like that. I'm going to type in just first as a shortcut for differences. So let's have a look at the differences. From 1 to 3 the difference is 2. From 3 to 6 the difference is 3. From 6 to 10 the difference is 4. 10 to 15 is 5. 15 to 21 is 6. And then if we look at the second set of differences, from 2 to 3 the difference is 1, 1, 1, 1. So this is the second set of differences. Doesn't like that. Let's see if I can... Okay, I don't want to overwrite it. I'll just leave that, we don't need it. So second set of differences, so that's telling you the model is an x squared model, power of 2. So it's a quadratic. So the cool thing is menu, statistics, stat calculations, and here's all the different models. Linear regression, quadratic regression, cubic regression. So let's go for quadratic regression. Tell the calculator where the data is. The x list with the n values, and the y list with the outputs, the number of cubes. I'm going to save the regression equation to F1. I'm always going to have F1 there. The only time I might not is if I've already used my calculator for other graphs and I've got other things sitting in F1. And I'm going to ask it to put it into column E, the results. There we go. So we've got the rule here. 0.5, 0.5, 1e minus 13. Now we've got to be careful, this 1e minus 13 is a tiny, tiny number, 0.0000000, something like that. So we're going to actually just think that's going to be 0. And there's the model, ax squared plus bx plus c. So we fit our numbers in the right place and we write down the function. I've got another slightly different way of doing this that I didn't show you before, so I'm going to show you this now. Document, insert, data and statistics, because I have got some data which I can plot, and it's n, and here it's the cubes. So you can see the visual on here, it's kind of a curved up. So that might give you a clue that it's not linear, that it's definitely quadratic. Now on this menu, I think this is actually even better, because menu, analyze, regression, so we get into the same menu, but now we've got the quadratic directly on here. And it gives us it written out in a nice fashion. But notice it's still got that weird bit at the end, plus 1e minus 13. This is the smallest number that it really is defaults to 0. So you would write down just this first part of the equation. Okay. But now I'm going to do something even fancier. Document, insert, graph. And the graph we're going to draw is the graph of f1, open bracket x. And that's great. But obviously this doesn't make sense because we've got negative x values. We've got x values 1.3, 1.4. We just want the table of values to go with it. So the shortcut is Control T. Now it should default naturally to x values of 1, 2, 3, 4, 5. You can also go back to negative values, but again, for the context of our question, it makes no sense to have negative n values. So you've got a very good way now of just looking at the 10th pattern has 55 cubes, and you can go all the way up to 105 cubes, 120. If you want to get rid of the table, you can just press Control T again, and it disappears. But really, it's all about the table for this question. One more final tip. If the numbers don't start at 1, 2, 3, or it goes a bit crazy, go to the menu, go to Table, and go to Table Settings. This allows you to start at any particular number and go up in any step size you want. So going up in step size of 2 is not sensible. Go up in a step size of 1 and start at 0. Press OK and you are in the right area. That's it.